All right, so we have this problem here. We have segment LK congruent to segment NM, segment KJ congruent to segment MJ. In this figure, we're trying to prove LJ congruent to NJ. So what's our first step to solving these problems? Well, looking at our algorithm, we start with drawing the T-chart and labeling statements and reasons. So I'm going to do that. I'm going to go ahead and draw my T-chart, label it statements and reasons. This may seem frivolous, but it's very important that we do this, statements and reasons. Then we need to do our second step in the algorithm, which is label our rows 1 and 1. Again, a step that you might think is pointless, but it is very important, especially when I'm coming around and grading and taking a look and trying to match up the statement with the correct reason. What do we do next? We take our givens and we put them in as statement number 1. So I want to put LK, or line segment LK, congruent to line segment NM, and then I'm going to say line segment KJ is congruent to, well, congruent to line segment MJ, and my reason is going to be given. The reason for the first statement is always given. What is the next step in my algorithm here? It is to take any congruency statements and convert them to equations using definition of congruence. So do I have any congruency statements here? Yes, I do. So I'm going to convert them into equations using definition of congruence. It's LK is equal to NM, and it's KJ is equal to MJ. Notice when I do that, the lines over the segments go away. Now it's measure LK equals to measure NM. Measure KJ is equal to measure MJ. So my reason for this is definition of congruence. Definition of congruence lets us go from congruency statement to equation. It also lets us go from equation back to congruency statement. Now what is my next step? Well, we go ahead and look at our algorithm, and the next step is if we're given any midpoints, we create more equations using definition of midpoint. Are we given any more midpoints here? Right? Well, if we were, it would say here that M is a midpoint, or it'd say that Z is a midpoint, but it does not. So we do not have any midpoints. We skip that step. So we skip step 4. We go to step 5. What do we do now? We look at the figure, and if we're given 3 points on a line, we use seg-adpos to create more equations. What does seg-adpos let us say? That the first part of the segment plus the second part of the segment equals to the whole segment. So I'm looking over here at this figure now, and I'm asking myself, do I have 3 points on a line? Well, we have this triangle, and it might confuse you, but we do have 3 points on a line. It's those 3 points right there, J, M, and N. So we can apply seg-adpos to those 3 points. It's first part of the segment plus second part of the segment equals the whole segment, namely Jm plus Mn equals Jn, right? Not only do we have those 3 points on a line, we also have those 3 points on a line. We got J, K, and L. So we're going to create another equation. It's first part of the segment plus second part of the segment equals the whole segment, namely JK plus KL is equal to JL. So I'm going to go ahead and write those equations now. It's going to be Jm plus Mn is equal to Jn, and then my second equation is going to be Jk plus KL is equal to JL, and my reason is seg-adpos. So I'm done with my step 5, right? The 3 steps here to create equations. And lastly, I'm using substitution to try to get to the prove statement. What am I trying to prove? LJ is equal to NJ. Okay, so I'm looking at my equations. What do I have? I have these 4 equations. 1, 2, 3, 4 equations. So I need to do substitution. Okay, so what am I going to do? Well, I'm looking at it and I'm trying to figure out, what do I do? Well, I could go ahead and take this Mn, and where can I put him? I could put him anywhere I see LK. Okay. And do I see LK here? No, I don't. Do I see LK here? No, I don't. Do I see LK in this equation? I don't, but I see KL. Okay. LK and KL are the same segment. It's just the order is different. Right? But for segments, the order doesn't matter. Right? LK and KL are the same segment. So I'm going to take my my NM, and I'm going to put it right here in the place of KL. Okay. Now, what else am I going to do? I'm going to take this MJ, I'm going to take this MJ, and I could put him anywhere I see KJ. Do I see KJ here? No. Do I see KJ here in this equation? No, I don't. Do I see KJ here? No, I don't. But you know what I do see? I see JK. right? I don't see KJ, but I see JK. Again, the order doesn't matter. So KJ and JK are the same segment. Okay? They represent the same measure. So instead of MJ, I'm going to go ahead and put it right in here in the place of JK. So let's go ahead and do that. So we have MJ plus MN. I'm going to go ahead and write it like that. Is equal to JL. So this is step 4. That's substitution. Okay. So now what am I going to do? Well, if you go ahead and take a look at this equation here and this equation here, right? They're the same expression on the left side of the equal sign. Okay. Look at this is JM, but mine says MJ. These are the same measure though, right? It's just the order is different. So these are the same. MN is the same. So these two expressions are the same. Okay. So what does that mean? That means anywhere I see this expression, I could put JL. Okay. And where do I see this expression? I see it right here. So I'm going to take this JL and I'm going to put him right in there in the place of that expression. And I can do that because JL is equal to that same expression. Right? That means anywhere I see this, I could put JL, and I see it right there. So I'm going to say 5 is JL is equal to JN. 5 is substitution. Okay. Okay, so now what am I going to do? Well, this doesn't look like this proof statement, but it is the proof statement. It's just the order of the segments are flipped around. This is LJ, this is JL. So let me go ahead and rewrite that. Okay, so I'm going to write it as LJ is equal to, I'm going to flip this one around too, as NJ. Okay, now we're looking like the proof statement. So on 6, it's going to be, I don't even know, maybe we could do substitution as well. And then now finally we need to go ahead and turn it into a congruency statement. So it's going to be line segment LJ with the line over it, congruent to line segment NJ. And that's going to be definition of congruence, right? Which lets us go from equation back to congruency statement. So this problem is a bit confusing because the order that we had the line segments in, the line measures, were in reverse, right? But you need to understand that JM is the same as MJ. These are the same exact measure of a line segment. Okay? So that means that this expression is the same as this expression, which means I could take this JL and put them right in there, right? Which we did. And then we also need to understand that we could flip these around, right? LJ is the same as JL. JN is the same as NJ, right? Which is what we want our proof statement to be. So we can go ahead and just flip that around. It's the same thing. So substitution, it's the same thing. And then we turn it into a congruency statement.